able to hear me, and is my screen visible to you? Good morning, Jia. Good morning, Akshita. Is my screen visible?
Yes, ma'am.
Oh. Yes, so we'll wait for like 2 more minutes, let others join. Okay, then we'll start the class. Okay, so in today's class, we are going to solve the question periodic classification and chemical bonding. Okay, so rather than periodic classification like chemical bonding, it has the highest weightage. So we are going to solve like more questions in chemical. Yes. Okay, this session. Fine. So moving to the first question. So the first question is like this is a PYQ question. Okay, so among there are like few compounds or ions given, you have to just see that which among the following has sp3 hybridized central atom. Which among the following has sp3 hybridized central atom? Okay, so is the question visible to everyone? Is the question visible to everyone? I'll share the screen again. Okay, so now is the screen visible to everyone? Okay, fine. So can you see the question? Can you see the question? Can you able to hear me? Okay, fine, fine, fine. Okay, so just tell me like how many number of species have the sp3 hybridized central carbon or central atom. Okay, so you have like I3 plus SiO4 minus SO2Cl2 XeF2 SF4 ClF3 NiCO4 XeO2F2 PtCl4 minus and SO2Cl2. XeF4 and SO2Cl2. Okay, so the total number of species having sp3 hybridized central atom is. Yes. So which among the following species has sp3 hybridized central atom? Is the question. Okay. Okay, so have you all got the answer? Is my voice breaking? Is my voice breaking? Okay, so am I audible? Okay, fine. Okay, so is my voice clear now? Fine. Okay, so have you got the answer? We'll solve the question. Okay. Yes. So you have to find out the total number of species having sp3 hybridized central atom. Okay. So how will you find out like whether it has sp3 hybridized? How will you find out? How will you find out? Yes. So for this, you have to know something called the steric number. Steric number. Okay, so how will you calculate the steric number? Z steric number is equal to the number of sigma bond plus lone pair. Will give you the steric number. Yes, will give you the steric number. So if the steric number is equal to 4, then how many orbitals are involved? Like 4 orbitals are involved. So one orbital from S from P. So 3 plus 1 is going to be 4. If the steric number is equal to 3, then what will be the hybridization? If steric number is equal to 3, then what will be the hybridization?
sp2.
Very good. It is going to be sp2. And if the steric number is going to be 2, the hybridization is going to be like sp. Yes? Okay. So now look at the question. Like you have I3 plus SiO4 4 minus SO2Cl2 and the compounds are given. So what you have to do now, you have to first draw the Lewis structure. You have to draw the Lewis structure. By drawing the Lewis structure, you'll get the number of sigma bond and the lone pair. You just add it together. If Z is equal to 4, then that is going to show the sp3 hybridization. Okay. So this is the basic concept behind this question. Okay. So we'll draw the Lewis structure. Okay. So starting with like I3 plus. Okay. So I3 plus what will be the Lewis structure? Like you'll be having 3 iodine atoms. Okay, so what will be the lone pair on the central iodine? You have like 1, 2, 3, 4. So to fill the octet, you need like 4 more electrons. Okay, so it means that you'll be having like 2 lone pair. You'll be having like 2 lone pair possible. So what is the steric number for I3 plus? What is the steric number for I3 plus? It is the number of sigma bond and the lone pair, right? So number of sigma bond for the central atom is 2 and the number of lone pair over here. What is the number of lone pair? You can see that number of lone pair is 2. Okay. So steric number is 4. So therefore it is going to be show sp3 hybridization. Can you do for like SiO4 4 minus? Can you draw the Lewis structure for SiO4 4 minus? So you have like 4 oxygen attached to silicon and all the oxygen has like minus charge. Okay, so minus, minus, minus and minus. So we know that oxygen must form a double bond and it should have like 2 lone pairs.
So here there is like one negative charge. It means that it is going to form like 4 single bond. Okay. Now what is the steric number? For SiO4 4 minus, it is 4. So this is also going to show like sp3 hybridization. Now moving to SO2Cl2. SO2Cl2. Okay. So what is the steric number here? You have to count only the sigma bond. Okay. You have to count only the sigma bond. So you have like 1, 2, 3, and 4. Okay. These two are pi bonds. So therefore we have 4. So this is also going to show sp3 hybridization. Do it for like HCF2. HCF2. Now, how many lone pairs on xenon you'll be having? Like how many lone pairs you'll be having?
Ma'am,
How many lone pairs you'll be having? Yes.
4. SiO4 have also lone pair, so why we are not consider lone pair?
Which one you're asking? Like
SiO4 4 negative.
SiO4 4 negative?
It has one lone pair.
See, SiO4 4 negative, already its octet is completed, right? See, 1, 2, 3, 4, 5, 6, 7, 8. Then where to put the lone pair? Will it have like any lone pair? Si?
Okay, ma'am, now understand. Sorry.
Okay, fine. Yes. So now moving to HCF2, like how many lone pairs it will be having?
Ma'am, 3.
1, 2, 3, 4. It will be having like 3 lone pairs. So what will be the steric number over here is 5. Okay, so will it undergo like sp3 hybridization? No, it won't undergo sp3 hybridization. So if steric number is 5, then what will be the hybridization? Can anyone tell the hybridization if steric number is 5?
sp3d.
Very good. sp3d. Okay, so p3 will have like 4 and you're just going to include 1d. If it is 6, it is going to be like sp3d. So this is sp3d. Now do it for like SF4. 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 Okay, so what will be the hybridization in SF4? Like, can you tell me like sulfur can have any lone pair?
Yes, one lone pair. Yes, one lone pair.
It will be having like 1 lone pair. Why? Why it will contain like 1 lone pair? Because we know that it belongs to group 16. It belongs to group 16. Okay, so in group 16, like how many maximum number of valence electrons could be present? Like 6. Okay, so this is said to be as like the expanded octet. Here octet is expanded. Okay, so now what will be the Z value over here is 1, 2, 3, 4, 5. Okay, so therefore it will also undergo like sp3d. Now, ClF3. What will be the hybridization for ClF3? Now, how many lone pair does Cl contain?
Two lone pairs.
Yes, very good. 2 lone pairs. Okay, so 1, 2, 3, 4, 5, 6, 7. We know that it belongs to group 17. So the maximum valence is going to be like 7. So 1, 2, 3, 4, 5, 6, 7. Okay. So now what will be Z over here? It is 3 plus 2, 5. So it is also like sp3d. Now moving to like NiCO4. NiCO4. CO4. Okay. Yes. So now what will be the Z number for NiCO4?
4.
Yes, it is 4. Okay. So therefore, it is going to be like sp3 hybridized. This is sp3 hybridized. Now moving to XeO2F2. XeO2F2. So double bond O F and F. So you have like 1, 2, 3, 4, 5, 6 electrons. So how many lone pair on xenon?
One lone pair.
One lone pair. So what will be Z over this XeO2 F2 is going to be like 5. Okay, 1, 2, 3, 4, 5. So it is sp3d. Now PgCl4 to minus, PgCl4 to minus, that is going to be
DSP2.
4. So, what you're asking? I couldn't get. Like someone was asking. Put it in the chat box. Put it in the chat box. Okay. So why here z is equal to 4? Why here z is equal to 4? See, PgCl4 to minus. Okay. So it means that what would be the oxidation state of platinum in PgCl4 to minus? What would be the oxidation state of platinum in PgCl4 to minus? So X minus 4 is equal to minus 2. So what will be X value over here? It is going to be plus. It is going to be like plus 2. Okay. So now, where does platinum comes in the periodic table? To which group it belongs to? Platinum. Where do platinum comes in the periodic table? Or tell me the outermost configuration of platinum. Where it comes?
76,
Platinum.
78.
Okay. So I'm asking like the outermost configuration of platinum. What would be the outermost configuration of platinum? Or tell like in the 3D series. Okay, will be we have the 3D series. We know the configuration of 3D series. Okay. So where does the platinum comes? Below?
मैम 46 और S
Where
इसमें
does
0 होते हैं.
it is going to be like, yes. So it is plus 2, plus 2. So what you're going to do is you're going to remove like 2 electrons. You're going to remove 2 electrons. Okay. So if you remove 2 electrons, then what will be the like how many chlorine you can attach over there? You have to see. Okay. So if you remove like 2 electrons, it is going to be like platinum 2 plus. You're going to remove 2 electrons. Okay. You're going to remove 2 electrons. So if I have like 2, 3, 4, 5, 6, 7, and 8. Okay. So I'm going to remove 2 electrons. So what happens like now one of the electron can move to the s orbital. Okay. One of the electron can move to the s orbital. If it moves to the s orbital, then what will be the hybridization? Using this we can do, right? This hybridization, like we have studied it in coordination chemistry. Coordination chemistry. Yes. So what would be the hybridization? What would be the hybridization? What would be the hybridization? Okay, so look over here. You have like, so what would be the configuration of platinum? It is going to be like 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the configuration, outermost configuration is 5D968S1 is the configuration of platinum. You're going to remove like 2 electrons. So you're going to remove 1 electron from S and 1 electron from the D orbital. So how many electrons? That is why I have written like here it is 8. Okay. So therefore, how many electrons will be having? Like 1, 2, 3, 4, 5, 6, 7, 8 electrons will be having. Will be having like 8 electrons. Okay. So one s orbital is vacant. One s orbital is vacant over here. So what would be like? You have to see like whether this chlorine is a strong field ligand or weak field ligand. Strong field ligand or weak field ligand.
Ma'am, it's strong.
Weak.
Chlorine is it is weak field ligand. Then whether the pairing takes place over there? No, pairing will not take place. Yes, pairing will not take place. So what will be the hybridization? Whether it is going to be the inner orbital complex or outer orbital complex.
Outer orbital complex.
It is going to be the outer orbital complex. So what will be the hybridization?
sp3.
If it is inner orbital complex, then what happens? It will give you like dsp2 as the hybridization. Okay. So now moving to like HCF4. HCF4. Fine. So now what is the Z value for what is the Z value for HCF4?
6.
So 1, 2, 3, 4. So how many lone pair you'll be having? In HCF4, you'll be having like 2 lone pairs. So Z value is going to be like 1, 2, 3, 4, 5, and 6. Okay. Now SOCl2. SOCl2. What will be the hybridization of SOCl2? So SOCl2, I'll write somewhere over here. So SOCl2. Okay. So what will be the number of lone pairs?
1 lone pair.
Okay, so 1, 2, 3, 4, 5, 6. Okay, so therefore, what will be the hybridization?
sp3.
Okay, so now what is the total number? P3 hybrid. Like count, you have like 1, 2, 3,
6.
and where is like HCF4? Okay, 4 and 5. And also like one more thing. Yes, Rohit, you're right. In case of like platinum, Cl, it acts as the strong field ligand. So therefore, the hybridization will be like dsp2. Okay. So in case of platinum, this one acts as the strong field ligand. Yes, Rohit is right. So therefore, we'll be having the answer as 5. Okay, as 5. Okay, got it, everyone?
Yes.
Okay, so now moving to the next question. Fine. Okay, so consider the following molecules. So it is also a PYQ question, okay? So count the number of atoms existing in their zero oxidation state in each molecule. You have to write the number of atoms which exist in zero oxidation state in each molecule. So you have to find out the individual oxidation state. Individual oxidation state. Individual oxidation state. So how will you find out the individual oxidation state? By writing the structure only, you can find out the individual oxidation state. Yes. So first starting with like Br3O8. Br3O8. Okay. So you have like 3 Br. So Br. Okay. And you have like 8 oxygen. So how to distribute the oxygen in these 3 Br? We know that Br, it belongs to like which group?
70.
Group number 17. So how many maximum number of bonds it can form? Like 7 bonds it can form, and oxygen, we know that it can form a double bond. So now I'm making a single bond between these bromine. So now this bromine, like how many bond it can form? It already it has formed like 1 bond. So remaining it can form like 6 bonds. Okay. And oxygen, we know that it forms a double bond. So I'm writing like 3 oxygen at the terminal bromine. And here when we take the bromine at the middle, it can have like 2 bonds. Okay. So therefore it will be like double bondo. Okay. So now we have to like do the individual oxidation state. Okay. So now how to do the individual oxidation state? Okay, so now what is the oxidation state of this oxygen is going to be -2. So what will be the oxidation state of bromine is going to be like +6. And here you have like 2 oxygen whose oxidation state is -2. So it is going to be like +4. And here you have -2, -2. So it is going to be like +6. Okay. So now does any one of the atom has 0 oxidation state in BrO3?
No, ma'am.
No.
No. So you have any atom with 0 oxidation state. Same way you go for like F2O. You go for like F2O. Okay. Fluorine, always fluorine, it can have only -1 oxidation. Okay. So now it will be having like -1. So you have like plus. So we don't have any atom with 0 oxidation state. Now do it for like H2S4O6. So you have like 4 sulfur. 1, 2, 3, 4 sulfur. Okay. Yes. So how many oxygen you have to distribute? Like you have to distribute 3 oxygens and you have like 2 hydrogen. So I'm making OH at the end. So remaining is 2 oxygen and 2 oxygen over here. So I'm just drawing the Lewis structure. Okay, fine. Oxidation, find out the oxidation state. Okay. So here it is like -2, -2. And what will be the oxidation state of this oxygen?
Plus minus 1.
What will be the oxidation state of? Yes. So here it will be like -2, -2, -1. So these two will get 2, 4, 5, -5. So sulfur will have like +5 oxidation state. Now what will be the oxidation state of the sulfur in middle? Like we know that this sulfur, two sulfurs, so same atom, and this sulfur also has attached to 2 sulfur, same atom. So what will be the oxidation state of sulfur in the middle?
0.
0, yes, is 0. So we have like 2 atoms having 0 oxidation state. Okay. And next is H2S5O6. H2S5O6. So here we'll be having H2S5O6. So I'm going to add like 1 more sulfur. Okay, 1 more sulfur. So what happens? Here I'll be adding 1, 2, 3, 4, 5. So this one will also have like 0. Okay, so here it will be like 3 and C3O6. C3O6, carbon, carbon, carbon. Okay, so C3O2, sorry, C3O2. So you have like oxygen, oxygen. So make a double bond everywhere. Carbon valency is 4. Okay, so now what will be the oxidation state of this carbon is +2 and the carbon in the middle will be like 0. So how many? Yes, you have like 1. Okay, so now what is the total number of atoms existing in 0 oxidation state? 3 plus 2 plus 1 is
6.
going to be like 6. Okay, so is this question easy? Yes, so it was a PYQ question which was asked last day. Fine. Now moving to the next question. Consider the following compound like O2, HF, NH3, H2, O2, CCl4, CHCl3, C6, and C6H. When a charged comb is brought near the flowing stream, how many of them show deflection as per the following figure? So here is the figure, like in the burette, you have the compounds. Okay, you are going to fill the compounds like one by one, and you're bringing a comb near it, charged comb. Okay, so this comb is charged. This comb is charged. So how many of them will deflect this comb is the question. Okay, is the question. Okay. So now, which type of liquid will get attracted towards the charged comb? Which type of liquid gets attracted to the charged comb? Which type of liquid gets attracted to the charged comb? Polar or non-polar? What type of liquid it should be, like whether it should be a polar liquid or a non-polar liquid? Very good. It should be a polar liquid. Okay. 1 second, guys. I'll be back. Okay, so it should be a polar liquid. It should be a polar liquid. Okay. So now what is the concept we are going to use over here is you have to find out like how many of the compounds are polar in nature. So that many of compounds will get attracted to the charged liquid. Okay. So like find out how many of them are charged. How many of them are
Gotcha.
charged? Okay. So like does O2 is a polar compound?
No.
No, because we know that both are have the same electronegativity. Yes, Rohit, you are right. So both have the same electronegativity. Okay, so therefore this one will not be a polar one. Okay, so here the dipole moment is going to be 0. Okay, whether HF is polar, we know that fluorine is more electronegative. It will pull the electron towards itself. So you have like a dipole. Okay, so therefore it is polar. H2 is polar? Yes, we know that. H plus, OH minus. So it is polar in nature. What about like NH3?
Polar
Like
in
NH3, how many lone pair you have? Like one lone pair. So the dipole moment will be in the direction towards the lone pair. And here we know that nitrogen is more electronegative. Okay, so you have the dipole moment is not equal to 0. Okay, it is acting in the same direction, so therefore it is also polar. What about like H2O2? It is also polar. Okay, what about like CCl4?
I'm non-polar.
lone polar.
Very good. Okay, so the dipole moment is acting in the opposite direction, so mu will be equal to 0, so it is non-polar. What about like CHCl3?
Polar.
Yes, so you have to replace like one hydrogen. So here you can see that it will be acting in the same direction, so polar. And what about like C6H6? It is also a
Non-polar.
symmetric compound, okay? So non-polar. It will be polar. So 1, 2, 3, 4, 5, 6. So your answer is going to be like 6. Okay, got this question, everyone? Ankit, got it? It is
Yes.
going to be like 6 compounds. Yes, fine. Now moving to the next question. Among H2, He2 plus, Li2, Be2, B2, C2, N2, O2 minus, and F2, find out the number of diamagnetic species. Okay, you have to find out the number of diamagnetic species. Here, I'll just give you a trick. See, you just calculate the total number of electrons in the molecule. Total number of electrons. Okay. So, if the number of electron is odd, it is going to be like paramagnetic. And if the number of electron is going to be even, it is going to be diamagnetic. And there is like one exception in even. Okay, if it contains like 10 and 16 electron, it is going to be like paramagnetic. This is because when you're writing the MOT, okay, so in 1s, 2s, there won't be a problem because you'll be getting like sigma 1 is sigma 1 is star, sigma 2 is sigma 2 is star. But when you're writing for the p orbital, you have like 2 pi orbitals and 1 sigma orbital. Okay, so here if it is going to be like 10 electron, you're going to like place one electron over the pi orbital. That's why it is going to be paramagnetic. Okay, so except like 10 and 16 electrons, all the even number of electrons will be diamagnetic and all the odd number of electrons will be paramagnetic. As I can say that odd number of electrons and number of 10 and 16 will be paramagnetic and remaining will be the diamagnetic. Okay, so this is a small trick. Else what you have to do, you have to sit and write the whole configuration in order to find out. Okay, so therefore we'll use this trick to find out. Okay, so among H2, okay, so whether it is going to be like paramagnetic or diamagnetic, how many electrons it has? Like 2 electrons, so therefore it is diamagnetic. It is diamagnetic. He2 plus. So what is the total number of electron in He2 plus?
3.
What is the total number of electrons? 3.
7.
So we know that para. Yes, it is para. Li2. How many total number of electrons is?
6.
6. So therefore it is going to be like dia. De2. What is the total number of electron in De2? 8.
8.
So diamagnetic. B2. What is the total number of electron?
10 but paramagnetic.
10. 10 it comes for para. C2. 12.
12.
Dia. N2.
14.
N2 is 14.
17.
Okay. And then comes the O2 minus.
7.
O2 minus. Okay.
17.
How many electrons you have? So therefore it is going to be like paramagnetic. F2.
18. Diamagnetic.
So diamagnetic. So how many diamagnetic we have? Let's take like 1, 2, 3, 4, 5, and 6. So the answer is going to be 6. Okay, got this question, everyone?
Yes, ma'am.
So if you want, like, you can use this trick. You can know this trick. Okay, so now moving to the next question. Among the triatomic molecules like BeCl2, N3 minus, N2O, NO2 plus, O3, SCl2, ICl2 minus, I3 minus, and XCF2, the total number of linear molecules where the hybridization of the central atom does not have contribution from the d orbital s. Okay, so you have to find like the total number of linear molecules where the hybridization does not have the contribution from the d orbital. Okay, so we have to find out the total number of linear molecules. Okay, so tell me like which one will give you the linear molecule? Which one will give you linear molecule? According to the VSEPR theory, yes, sp hybridization will give you the linear molecule. Okay, and if you have like, it will give you like linear molecule. Okay, and also if you have like AB to L2 pair, what will be the hybridization? It is going to be like sp3d. Okay, and here it will be showing the linear one. Okay, Yes, lone pair. It has like two lone pairs. So A, B2, and it has like two lone pairs. Okay. So therefore, like it should be A, B2, L2 is going to show the linear. And also we know that A, B2, L3 is also going to show the linear. Okay. So now what is the thing is, the hybridization should not have the contribution of the d orbital. It should not have the contribution of the d orbital. So it should be like purely of S and P. Okay. So now find out the hybridization of BeCl2. What is the hybridization of BeCl2? What is B over here is 2. So therefore sp hybridization. So it is going to be like linear. N3 minus. Just draw the Lewis structure of N3 minus. Yes. So now what is the hybridization of the central nitrogen over here? It has
SP.
like a triple bond, so sp. And N to O. N to O. So N triple bond NO. So what is the hybridization over here is like sp. And NO2 plus. NO2 plus. So you have like two sigma bond. This is also going to be like sp. Okay. So what about O3? O3. Okay. What is the hybridization over here like for O3?
SP.
So the hybridization is going to be like sp2 because you have like one lone pair. Okay. So therefore it is going to be like sp2. So this one will not show linear. And moving to like SCl2. So how many lone pairs? Two lone pairs. So 1, 2, 3, 4, sp3.
SP3.
It is also not going to be linear. ICl2. ICl2. Okay. So what will be the thing over here?
SP3.
So therefore, what will be the hybridization? Okay, check how many electrons you have, like 1, 2, 3, 4, 5, 6. So you should have like one negative charge over there. You have a negative charge. So now what will be the hybridization over here? What will be
SP3.
the hybridization? sp3d. Okay, but in the question, the central atom should not have the contribution for the d orbital. So will you consider this for the answer now?
Not considered.
No. Okay. Now moving to like I3 minus I.
So you have a minus charge. So 1, 2, 3, 4, 5. Okay. Will you consider this one? It also involves the orbital consider. Okay.
Moving to like XeF2,
मैम उसमें भी d orbital
you
आता है.
have like 3. So this is also d orbital. So it will not consider. So what is question, everyone? For this question? Yes. So moving to the next question. Yes. A list of species having formula ZX4, Z4 is given below. Defining shape on the basis of Z and X and Z atoms, what will be the total number of species having the square planar shape? Okay. So what are the species? Which species will have the square planar shape is the question. Okay. So now moving with XeF4. HCF4. Okay, so how many lone pairs? 3, 4, so
Two
5,
lone
6,
pairs.
7, 8. Yes, 2 lone pairs. Okay. So now what is the type? It is AB4E2 type. You have like 2 lone pairs. So now what will be the shape? Shape is going to be like square planar. It is going to be like square
Tetrahedral.
planar. Yes. And SF4. SF4. What will be the shape for SF4? How many lone pair it will be having? Sulfur, it will be having like 1 lone pair. So what is the shape of SF4? If it is AB4E type, what is the shape? You can see just it looks like a seesaw, like opposite. So therefore it is seesaw. Seesaw. Only in this shape, the repulsion will be minimum. Okay. And SiF4. SiF4. What is the shape of SiF4? Is there any lone pair on silicon? It belongs to group number 14. So it doesn't have any lone pair. So what is the type is AB4? What is the geometry or shape of AB4?
Tetrahedral.
Tetrahedral. Okay. Next comes BF4 minus. BF4 minus. BF4 minus. Okay, so what is the hybridization over here? Or just tell me the geometry. It is also of AB4 type. So it will be having tetrahedral. CuNH3 4 2 plus. CuNH3 4 2 plus. So here what you will do? Like you will be having CuNH3 4 2 plus. You have to first calculate the oxidation state of copper over here. Okay. Copper, we know that like amines are having, they are like neutral ligands. So what is the oxidation state of copper is going to be like 2 plus. And we know the configuration of copper is like 3D9 4s1. Okay, 3D9 4s1. So what will be the geometry? Like you have to remove 2 electrons. Okay. So therefore, what will be the like geometry of CuNH3 4 2 plus? CuNH3 4 2 plus. What is the geometry of CuNH3 4 2 plus? Whether its hybridization is
Tetrahedral.
sp2 or dsp2. It is dsp2 square. Okay. Now FeCl4 minus. FeCl4 2 minus. What is the hybridization of FeCl4 2 minus? Whether it is sp3 or dsp2. The oxidation state is like +2. Okay, so you'll be having 3d6, and we know that it is the weak field ligand. Okay, so it is like a weak field ligand. So it is a weak field ligand. So therefore, what will be the hybridization? What will be the hybridization? Is going to be sp3. It is going to be like sp3. And what about like COCl4 to minus? COCl4 to minus, here too the oxidation state is +2. Okay, so therefore it will be sp3. PtCl4 to minus, just we have seen that even though it has weak field, it will have the dsp2 hybridization, so therefore it will be like square planar. Now tell me like what is the total number of things having square planar geometry? HCF4 is having. Okay, and this is square planar, and again okay.
Then CuNH3 is tetrahedral.
Cu
NH3.
CuNH3 4 2 plus. So what is going to be the hybridization over here? Or just you can see like whether this NH3 is a strong field ligand or weak field ligand.
Weak field.
NH3
Weak field ligand.
is okay. How will you like in the spectrochemical series? It will be like carbon, oxygen, and hydrogen. Okay, so this is the trick to find out whether it is a strong field or weak field. So from water, it is going to be a weak field ligand. So the nitrogen containing ligand will be strong field ligand. Got it? Varun? So what are the thing which has the square planar shape is HCl4 has, okay, and then is BrF4 minus,
Now clear.
BrF4 minus, copper. Not clear, Varun. You know the spectrochemical series, okay? So now I'll just give you a
Can you
trick
rewrite
to identify
configuration of
whether it is
CU?
a
You wrote wrong CU configuration.
copper. Sorry, it is 3D10-4S1. Yes, it is 3D10-4S1. Yes, 3D10-4S1. So you have to write, remove 2 electrons, then it becomes like 3D9. It becomes 3D9. Got it?
Yes, ma'am.
Okay, fine. Okay, so HCF4, BrF4 minus, then the copper complex and the platinum complex. So therefore, it is going to be like, answer is going to be like, okay, moving to the next question. The correct molecular diagram for F2 molecule in the ground status. Okay, it is also it is an MCQ single correct answer, which was asked last year. Okay, so which will be the correct orbital diagram for F2 molecule? So we know that in MOT, okay, MOT, we have studied like 2 different types of writing the configuration. Like one is having the configuration up to 14 electrons, and the configuration which is greater, the configuration for which the number of electron is greater than 14. Okay, number of electrons is greater than 14. So greater than 14. So here, what happens when it is like less than 14? What happens? So up to 14, you'll have, like when I take nitrogen, N2, we know that it has having 14 electrons. Now, what is the outermost configuration of nitrogen is to S2 to P3. So you have like three electrons. This is for one nitrogen and this is for the second nitrogen. So you have like unpaired electrons. So when you have like unpaired electron, then sp mixing is possible. S orbital, p orbital mixing is possible. But when I'm going to add like one more electron, if it is going to be like 15, then you have to add one more electron over here, and this orbital gets paired. So therefore here sp mixing is not possible. Sp mixing is not possible. So what will be the configuration for greater than 14? We know that sigma star, okay, for the 1s and 2s we know. I'm just writing for the pi orbital alone, okay. So it is going to be like sigma 2a star, and here sp mixing is not possible. It means that after the sigma, p orbital, pi orbital will not come. Again, what will come? Sigma only will come. Okay, so sigma to pz, and then comes pi to px to py, and then it's antibonding molecular orbital. So this is the order. Okay, so here you can see that mixing is not possible. Okay, mixing is not possible. So now you have to write it for F2 molecule. You have to write it for F2 molecule. Okay, so if it is like, if it is for F2 molecule, what is the total number of electrons in F2? What is the total number of
18.
electrons in
18.
F2? Yes, 18. So you have to, it is like greater than photon. So you have to check like which has the configuration greater than photon. It should have like sigma, after sigma to S, it should be sigma to PZ, not pi. So here, when you check over here, you have sigma pi. Okay. And when you check over here, it is like sigma pi. And here it is like sigma, sigma. And what about the fourth option? 1 second. So the fourth option is also like sigma, sigma. Okay.
Ma'am,
So now count the number of electrons. Count the number of electrons. So 1, 2, 3,
14
4, 5,
electrons
6,
in
7, 8,
each
9, 10,
case.
11, 12, 13, 14. 14 electrons. Here it is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14 electrons. Okay. 14 electrons, and in the oneness you'll be having like 17, 18. Now, here is the thing where the change happens. Here is the thing where the change happens. Okay. So, which one is going to be the right one? Whether it is going to be like sigma, pi, it should be get filled first, or this one. Which one is going to be right? Like
Third
option,
is right.
yes, third is right. So this is going to be the right. Okay, clear? So if it is like less than 14, then SP mixing is possible. So then after sigma to A star, you'll be having pi to PX, pi to P. Okay, yes. Clear with this
Yes,
question,
ma'am.
everyone? Okay. Now moving to the next question. Okay, so each of the following option contains set of 4 molecules. Identify the options where all 4 molecules possess permanent dipole moment at room temperature. So you have to find out the compounds. Okay, find out the option which has set of all the 4 molecules possessing the permanent dipole moment, and check this is the MCQ. More than one correct answer. More than one correct. So among the 4, like you have to be very careful while choosing the options. Okay, fine. So now moving to the part. Okay, can you guess like any options? First, you try to omit. Like we know that if the molecule is under symmetry, it is not going to have the dipole moment. Okay, so you can like omit something. If it has symmetry, you can omit that option and then you can check. Okay, so it contain like any symmetry
Symmetry
over
first.
here? In the first one, is there any symmetry like SO2, C6H5,
SO2.
Cl, H2C, BRF5? Is there any symmetry?
SO2 and S2SE.
No. SO2, it will be having like, okay, it has the lone pair, right? Sulfur has the lone pair. So, can I say that it is under symmetry? No, it is not under symmetry. Symmetry molecule should not contain the lone pair. If it has the lone pair, then it will show the dipole moment. Okay, so it doesn't show symmetry here. Does any compound show symmetry?
CO2.
Like in option B, yes,
CO2.
we can see like CO2 it shows. Okay, DCl3 it shows, AD3 type it shows. Okay, now moving to see whether does some show the symmetry over here? No. NH3 it has lone pair. Here too it has like lone pair. BF3, yes, BF3 shows symmetry. Okay, SF6 it shows symmetry. So therefore, these two doesn't show symmetry. So A and C are the right option. Okay, rather than sitting and drawing and finding out the dipole moment, this is a quick method. Okay, so in this, like you can eliminate the thing. Okay, so whenever there is like MCQ of this type, you can think over like, is there any
Okay, got it, everyone?
Yes, ma'am.
Okay, now moving to the next question is the first, second, and third ionization enthalpy of four.
The first
Plus 1 plus 3, where n is less than 10 are tabulated below. What is the value of n? Okay, so this is a PYQ question from periodic classification unit. Okay, they have just listed you out the first, second, and third ionization enthalpy of 4 atoms whose atomic number is n, n plus 1, n plus 2, and n plus 3. And they have given a clue like hint n is less than 10. Okay, n value is going to be like less than 10. What will be the value of n? What will be the value of n? Is the question. Can you like guess any options? Can you just
9.
yes, yes, very good. I got answer from who answered? Rohit. Okay, so n equal to 9. N equal to 9 is the right answer. Okay, so have you got the answer? Like when you check over the thing, right? So you can see that this one has ionization energy 1 and ionization energy 2. You can say that there is a drastic increase in the ionization energy 2. When will you have the drastic increase in ionization energy? We know that ionization energy is removing electron from the outermost orbital. So can I say that this has the pseudo inert gas configuration? So that is why the value over here is like high. The value over here is like high. Okay, so now, and this one also you can see like, if I take this one again, here you can see that it increases overall. Okay, but here the difference is like high. Okay, so now which group has the pseudo inert gas configuration? Like which has the pseudo inert gas configuration? Which has the pseudo inert gas configuration? That is like the outermost configuration should be equal to it should be like the inert gas configuration, or it will have the half filled or completely filled thing. Okay, so when I take like beryllium, can I say it has like 1:2, 2:2? Yes, 2:2 it has. And when I take like nitrogen, it has like 1:2, 2:2, 2p3. Okay, so now beryllium, it belongs to group number 2, alkaline earth metal, alkaline earth metal, alkaline earth metal. So removing the electron from the completely filled orbital, it needs more energy. So ionization energy will be high. Ionization energy will be high. Okay. So now this is for n plus 2, n plus 2. Okay, and here I'm going with the second ionization energy. So second ionization energy is high means I will remove the first electron easily. Okay, after removing, I'll find like second electron, it will be having the pseudo inert gas configuration. So when I take like if I'm considering like group number 2, okay, n value is going to be like here n value is should be like the total should be equal to 4. Okay, total should be equal to 4. But I'm removing the second electron only. So therefore, you have to write the thing which is like before. So group number 1. Okay, if I'm writing like group number 1, then it doesn't have any meaning, right? That is the first element. If I'm writing the first element. But if I write the second element in the group number 1, okay, so that is like after lithium, you have sodium. You have like sodium. So if I write sodium, I have removed like one electron already. So we have like Na plus. So what is the outermost configuration for Na plus is going to be the neon configuration. You have the pseudo inert gas configuration. So removing electron from this is going to be like harder. So N plus 2 is 11. It means like N plus 1 should be 10. N value should be 9. Okay. So what will be the value of N? N is going to be like 9. Got it, everyone? Got it? This question? Clear? Any doubts with this question? Rohit, Varun, Ikshita, everyone? Clear? Okay, fine. Now moving to the next question, like the correct order of radii is. Which is the correct order of radii? Which is the correct order of radii? Okay, so the options are like nitrogen, beryllium, boron, F minus, O2 minus, N3 minus, sodium, lithium, potassium, Fe3 plus, 2 plus, and Fe4 plus. We know that when you move along the period, what happens to the radii?
Decreases.
Radii decreases. Okay. And here you can see that beryllium comes in the middle. Okay, it means that the option is going to be like beryllium. It should be beryllium, boron, nitrogen. So the order should be something like this. Okay. Now you have like charge species. So we know that the radius is directly proportional to
Charge.
which charge? Which charge?
Anion.
Like negative charge? Yes, anion. As the anionic size increases, the radius will increase by cation. Okay, so I can say it is directly proportional to negative charge, inversely proportional to the positive charge. Okay, so as the negative charge increases, the radii will increase. So here you can see that negative charge increases, radii
Yes.
increases. This one is right. Okay, what about like option D? It is inversely proportional. It is inversely proportional. So as the negative positive charge increases, radii should decrease, but here it is increased, which is wrong. So option B is the right answer. Clear, everyone?
Yes.
Yes. So next comes the multiple choice question. An element has the maximum values of quantum numbers, maximum value of n equal to 4, maximum value of L equal to 2, maximum value of n equal to plus 2, and maximum value of S is equal to plus half. Then select the incorrect statement. You have to select the incorrect statement, not the correct one. Incorrect statement. Okay. So while like this questions are asked like statement questions, like 2 times you read the question whether they have asked for the correct statement or incorrect statement. Okay. So while like marking itself, we ourselves like do the mistake by marking the correct option. Okay. So like read the question twice to get the question properly, and the question is to select the incorrect statement. Okay. So the first statement is okay. Can you just give me the answer? Anyone? Everyone try to get the answer for this question. N value is 4, L value is 2, N equal to plus 2, S is equal to plus. Then what will be the incorrect
A
statement?
option.
Okay, it is an MCQ of multiple choice. So more than one option could be also be your answer. Okay, so we'll check. So element belongs to 5D series. So N value equal to 4 means what would be the D series?
3D.
3D. Yes, so it is given as 5D, which is an incorrect statement. An element must belong to P block. If L equal to 2, okay, what will be the block? If L equal to 0, it is S. L equal to 1 is P. L equal to 2 is D. So, but it has given as like P block, which is also incorrect. An element must have at least 4 electrons in the d subshell. It can have at least 4 electrons in the d subshell. Is it true? Is it correct or incorrect? We know that D has like how many subshell? It has like 5. 1, 2, 3, 4, 5. So it can contain at least 4 electrons, which is correct statement. And element, it belongs to the 4th period. Okay, does the element belongs to the 4th period? Does the element belongs to the 4th period?
Yes.
Yes. So therefore, incorrect statements are A and B. A and B are incorrect. Okay, got it? Yes. So moving to the next question. Okay, which of the following is our correct order of ionization energy? Which of the following are correct order of ionization energy? Correct order of ionization energy. So when you move along the period, ionization energy decreases. Sorry, ionization energy increases, and down the group, ionization energy decreases. So here, copper, silver, and gold, it belongs to the same group. Okay. So here, everything, it belongs to the same group. So the ionization energy should decrease when you move down the group. Okay. So which is correct order of ionization energy? Okay. So what should be the order over here is like copper, silver, and the gold. Okay. But here the order
B is
is wrong.
correct.
Yes, B is right. B is right. And palladium, platinum, nickel, it should be like nickel, palladium, platinum. The order is wrong. And aluminium, gallium, boron. Boron, aluminium, and gallium should be there. And look over the order, right? Boron will have the maximum. It will have the maximum. And gallium and aluminium. See, they have given like it is just equal to, less than or equal to. That is, gallium is more than that of aluminium. Is this true? Like, can you say that there is some sort of transition metal contraction for gallium? Like lanthanide contraction?
Yes,
Does
ma'am.
it experience the transition metal contraction? So as the contraction happens, what happens to the radii will decrease. So you have to like spend more energy. So when you compare these two, right, gallium will have the energy which is equal to or greater than that of the aluminium. So option D is also right. Okay, see the symbol over here. So B and D are the right. Okay, then the next question is, okay, the formation of oxide ion requires first an exothermic and then an endothermic step as shown below, which is not the cause of the above fact. Okay, which is not the cause of the above fact. What they have given is, the first step is like it is exothermic and the second step is like endothermic. What is not the cause about the above fact? Is it because like oxygen is more electronegative?
No,
Is it
ma'am.
because like, no. Okay, oxygen has higher electron affinity. Or look over the next option. O minus ion has comparatively larger size than the oxygen atom, or O minus ion will tend to resist the addition of electron. Which is the cause? Or tell me like among the four, which is the cause? Why the first ionization, first electron affinity, that is electron gain enthalpy is negative, and here it is like positive. What is the
D
cause?
should be the cause. D.
D is the cause. O minus ion will tend to resist the addition of electron, right? So already like it has gained like one electron. So it will resist the addition of electrons. That is why you need to supply energy to the energy is required to add the electron. That is why here the enthalpy is positive. Okay. So this is the cause. So option A, B, C is not the cause. So A, B, and C are not the cause for this part. Okay. Got with this question? Okay. So in which of the following statement is the correct order with respect to the given property? Which is the correct order with respect to the given property? So they have given you like ionic mobility order, hydrated radius order, bond polarity order, and electronegativity order. So in which of the following statement is the correct order with respect to the given property? Can you guess the options? Okay, so can I say that ionic mobility is inversely proportional to the size of hydrated ion? Yes, ionic mobility is inversely proportional to the size of the hydrated, which has the Fe3 plus or Fe2 plus,
A is correct.
which has the more size. So therefore, what
Yes,
happens to the ionic mobility? It should be like maximum hydrated ion size for Fe3 plus is larger, so mobility should be like minimum for Fe3 plus. So the order is wrong over here. And Br minus Cl minus F minus, what is the hydrated order? So we can say that smaller the size, more is the hydration. More hydration. So is the hydrated radius order true? Yes, it is true. Okay, F minus is small in size compared to Cl, and Br minus is large in size. Now comes the bond polarity order. Bond polarity order. Bond polarity order. Is the bond polarity order is right? Is the bond polarity order right? You have like CH3. You have like ASH3, and you have like antimony. So all this belongs to like group number 50. Group number 15. So when you move down the group, okay. So will it, do you remember the Dragos rule? Do you remember the Dragos rule? Yes. So here we have studied Dragos rule when it is attached to the atom, like small electronegative atom. This hydrogen is having, it is not like much more electronegative, it is less electronegative atom like hydrogen. What happens to the bond angle? Bond angle will be like approximately equal to 90 degrees. Okay. So below the group number, when you go to like group number, period number 3, 4, 5, the bond angle will be approximately equal to 90 degrees. So what would be the bond polarity order? It means that here the bond angle is maximum. So what would be the polarity? Polarity will be like minimum over. Okay. And the electronegativity order, which is like more electronegative, carbon or sulfur, which is more electronegative. So we have like carbon, oxygen, and sulfur. And we know that when you move down the group, electronegativity increases. So sulfur is going to be like more electronegative than carbon. And when you compare like boron and hydrogen, like what would be the electronegativity order for boron and nitrogen? For boron and nitrogen, what would be the electronegativity order of boron and hydrogen? Which is going to be like more electronegative? I can say that electronegativity value according to the Pauling scale is 2.1 for hydrogen. Okay, for hydrogen, the electronegativity is like 2.1. It is going to be like 2.1. So is the electronegativity of boron is going to be like greater than 2.1? No. Okay. So therefore, option B, C, and D are going to be the right answer. Moving to the next question. Okay. So the difference in electronegativity of two atoms of ionic character is 19. Be the difference in electronegativity. So what is formula to calculate the percent ionic character? Which formula I can use, like Haney-Smith formula? What is the formula to calculate the percentage ionic character? Percentage ionic character is equal to 16 into difference in electronegativity plus 3.5 into difference in electronegativity the whole square. So this is the formula to calculate the percentage ionic character. Now the percentage ionic character is given as like 19.5, okay, is equal to 16 times of the difference plus 3.5 times difference square, okay, delta square. Okay, so now the percentage difference in electronegativity of two atoms they have given. Okay, so electronegativity between the two atoms, is 19.5%. You have to find out the delta element. Okay, you have to solve for delta. So what will be the, you can do it. Okay, so take this question as homework. You can use the formula to find out the delta. And like I have, okay, so I have like a review to homework. Okay, so here you have to find out the number of pairs in which electron affinity of second element is more than first element. Okay, so the pairs are like fluorine, chlorine, one pair, carbon, nitrogen, oxygen, nitrogen, third pair, fluorine, neon, fourth pair, boron, carbon, fifth pair, oxygen, sulfur, sixth pair. So you have to find out the number of pairs in which electron affinity of second element is more than the first element. Okay, so you can screenshot this question, else I'll be sending you the class notes. Okay, so there you can look for the question and find out the answer. Okay, and also I'll just send you some DPPs to solve. Okay, have you solved the DPP which I sent for solution unit? Have you solved the DPP for solution unit? Yes. Okay, solve it and put it in the group. Okay. Fine. So that's it for today. And I'll meet you like tomorrow. Okay. So what is the chapter for tomorrow? So that you can revise and come fast. Okay. Yes. Okay, so tomorrow's classes will be solving questions in D and F block elements. Okay, so go through the synopsis, or if you have any short notes, go through it and come. So therefore, we can solve questions on D and F block. Yes. Okay, fine. Thank you all. Thank you.